Good evening. So just started a couple minutes early. So welcome to tonight's stream. So if you're new to the channel, welcome. Now I'm mainly doing this for people that are sitting the exams at my school, but I understand that a lot of them have physics tomorrow. So probably won't have too many people turning up today, but that's okay. I will just, if there aren't too many, so my priority for the stream is that I want to, address people's questions. So if you have any questions, you can just type in the chat and I'll attend them. No, I'm not gonna, well, with mock exam leaks, you already know what's gonna be in the exam, and it's not hard. It's really, science exam, like chemistry exams are very predictable. I can tell you that right now. So here are the leaks. So in your 2.4, you can expect Lewis diagram questions, polarity questions, shapes and molecule questions, in type of solids questions, enthalpy calculation questions, and for organic chemistry, you will be given drawing, naming, cis and trans isomers, major minor products, the Markovnikov's rule, Zaytev's rule, flowchart, distinguishing tests, and what's the other thing called for structure for 2.6 for chemical reactivity, your race reaction, equilibrium, and the Chatelier's principle. Writing KC expressions, and then shifting left and right, that sort of stuff. And then you got the pH calculation. Your strong acid, strong base completely dissociate, weak acid, weak base partially dissociate, and then you look at electrical conductivity and all that sort of stuff. So there you go. I just leaked the entire exams to you, Ash. You're welcome. Surely there won't be pressure questions. Why wouldn't there be pressure questions? Okay, so if anyone has any specific questions, so I can always go through any specific questions. So Ash asks if as a major you reckon our school organic tests are a bit too long. Yeah, the thing is, mate, like you would notice in all your subjects, I had a chat with some of the year 13s today. Our year 13 chem exam was very fair, but they were complaining about stats. They said the stats was way too difficult. And that's the thing, we tend to make our school exams a little bit difficult. It's just how it is, because we tend to buy the exams from outside sources, and you have to remember with NCEA exams at the end of the year, one thing that NCEA does is that they don't make the exams too difficult, because we have what we call quotation mark world leading education, and it's not a very good education system if your grades or your achievement is very, very poor. And our achievement has been very, very poor for the past 5 to 10 years, and you can see that in our science, our math, in our literacy, in our numeracy, in the OECD tests and whatnot. We're having a landslide on there. But what does NCEA do? Let's just make our tests easier so everyone get really good grades. So we have a world-leading education, which is an absolute joke. Okay, so the NCEA exams at the end of the year tend to be easier, not because it's just because they just want majority of people to pass. So that's just how it is. Yeah, that's the reality. I've been doing this for too long to ignore this. So sorry for the bit of vent, but it is what it is, and I'm not the only one thinking this way. But let's get to some chemistry questions. All right, so Stacey asks, could you go over carboxylic acid, and enough of me rambling, let's go do some chem. All right, so this is organic carboxylic acid, and where is it? Carboxylic acid and salt. Okay, so with your carboxylic acid, where's my mouse? Is my mouse even connected? Is my thing even connected? Hold up, my thingy-majiggy. Why is it not connected? Excuse me, my tablet is having a strike. Okay, so it should work now. Okay, let's start tonight's tutorial. Okay, so if you got carboxylic acid, so this is a carboxylic acid. Why is this tablet having a spaz? I don't even know why is it doing this. I'm just gonna. What's wrong with my thing? All right, it should work a little bit better now. I hope. Okay. Sorry, just think it's time to invest in a new PC. But okay, so if you got your carboxylic acid. Okay, so doesn't matter what it is. And what you do when you react with the carboxylic acid, you normally react with a carbonate. Okay, so with the carbonate, so in year 11 you did this. You did acid plus carbonate turning into salt plus CO2, carbon dioxide plus water. Okay, and what that means, so I'm just going to move this around. So you need to make salt, and you need to make CO2, you need to make water, and this is how we use this as a distinguishing test. I think someone asking about distinguishing tests for acid. So the carbonate is a really good example to test for the acid. So that's how we can tell, because you see the bubbles. Okay, so let's give you a really easy one from year 11, right? So if you like say you have HCl plus Na2CO3, this is here Na2CO3. If you remember this from level 1 acids and bases, then you should be good. So Na2CO3, this turns into NaCl plus H2O plus CO2. All right, this is year 11. This is nothing new here. So because you got 2 CNAs, so that means we need 2 here. And because you got 2 Cls, we need 2 here. Okay, so that's balancing equation. So what are we doing in year 12 is actually nothing too tricky. Is that you simply replace this with this. Instead of using HCl, you just use COOH. Okay, and then the rest doesn't really matter. Why is my tablet having a spaz? It just really doesn't like me tonight. So the COOH, and then this is whatever. Okay, so can you see what happened with the carboxylic acid is that as an acid they always lose the H. So you lost this H, you lose this H. So what is left behind is your COO, what is your left behind is your Cl. So what's going to happen, the leftover is going to combine together. So your Na will combine with the blah 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 COO, and we normally don't write it like that. We just write copy the rest, it just becomes COO Na. Because if you compare what we have here, oops, sorry. If you compare what we have here, I think it's OneNote that's bugging. We have this and look at this. Can you see that's very similar? Okay, so I've simply just replaced the Cl with the rest of the carboxylic acid minus the H. And then what do you make? Again, you make H2O and you make CO2. Okay, and how can I balance this? So this is 2 Na, this is 1 Na, so you multiply this by 2, you multiply this by 2, which is exactly what we've done over here. Okay, so I'm just gonna close my stupid OneNote. It just doesn't like me tonight for some reason. Okay, so hopefully that will help you with the carboxylic acid. All right, next one, I did my K-mark. Hopefully that went all right. So when you have to describe how to use a chemical reaction to distinguish something like alkane. Okay, so for example, let's see if this is much better. Let's say the distinguishing test, you use Br2 to distinguish alkanes and alkanes. Okay, so alkanes have double bonds, alkanes is just easy single bond. So this will go from orange to colorless straight away. You probably know the colors already straight away. And this one you need UV light, and it does the same color change here but very slowly. How do you write the equation? Like say if I have something like this, like say propene, if I react this with Br2, what's going to happen? This double bond is going to break, and then you are simply going to add these two bromines onto the double bond. So that's your equation. Okay, so you just need to be able to produce a chemical reaction for something like this if they ask you to do so. And if they normally do that, that is an excellence. Okay. What did the last one? Well, if they don't make the test so hard, then why won't they make it so extra easy? Okay, so yeah, reactivity is actually the easiest one, to be honest. And the thing is, guys, if you're considering doing level 3 chemistry, doesn't matter which school you're at, you shouldn't SNA any one of the 3 papers, because your 2.4 becomes 3.4, and it's literally the same thing but with more shapes and a little bit more content. Organics becomes 3.5. You need to know what you've learned this year on top of the year 13 stuff. So it's definitely not going to be easy. So if you can't do level 2 organics, you're going to fail at level 3 organic. I'm just going to say that right now, okay? Because you're not magically going to relearn level 2 stuff next year and, you know, get another 5-6 weeks of year 13 content in your head if you can't do the year 12 stuff. Structure reactivity in year 12 is actually, I don't know, when it gets to year 13, it becomes really calculation heavy. 90% of the questions are calculation based. It is personally my favorite external to teach and to do, because it's just so easy. Like, considering, you know, imagine writing an hour for 10 minutes for structure and bonding for a quiz for 3.6. I can do that in like 25 minutes with all calculations and get 24 out of 24 because it's all calculation. Okay. Oh, someone donated. Okay, no worries. All right, next one. So could you go over enthalpy calculation? Yes, Iris, I can definitely do that. So with enthalpy calculation, there are 2 types of enthalpy calculation. Let's just say 2A plus B turned to, let's say, 3C. Let's say this enthalpy is positive 100. Let's just give it a nice and easy number. Okay, doesn't matter what those things are. Let's just say the 2 types of question. So first type of, well, actually 3 types of question. The first type of question, they go, okay, so let's say I reacted 10 grams of A. I reacted, that looks like log, I don't have the number. Let's say 15 grams of A has been reacted. Is reacted, How much energy did I absorb in this particular experiment? Okay, and they give you the mole. They give you the mole of A, let's just say 10 grams from, I'm just making this up, okay? So the first thing that you need to do is to understand this. You need to understand this awesome equation that you've been provided. And I want you to translate, you need to be able to translate this, okay? So, you know, just do this with me. So read this. So every 2 moles of A react with 1 mole of B, I make 3 moles of C, and during this process I absorb, plus sign means absorb, I absorb 100 kilojoules of energy. So if I'm looking at specifically at A, that means for 2 moles of A, it's in the equation, 2 moles of A, I absorb 100 kilojoules of energy. So that means for 1 mole of A, I absorb 50 kilojoules of energy. Okay, so 1 mole is 50. That's the conversion rate. You can think of it like that. Okay, so how many moles do I actually have? I have 15 grams. I have 10 grams per mole. So that means you can do n equals small m divided by big M. So that's 15 divided by 10, and that's 1.5 mole. So 1 mole is 50. What's 1.5? So just 1.5 times 50, and that will give us 75 kilojoules of energy. Okay, so that's one particular way they can ask you. Another way they can ask you is thus. Let's just go back and write the equation again. So 2A plus B turning to 3C. I'm sorry if I'm not getting to your question. I'll get there. Okay, don't worry. I'll get there if you just wait patiently enough. Because some of the other questions that you're seeing right now could potentially be something that you don't know either. So it'd be worthwhile to see what other people ask. All right, so for this one, let's just say I released 1500 kilojoules, absorbed, sorry, of 1500 kilojoules of energy is absorbed. How many grams? How many grams of B did I have to chuck it in there to make this happen? You know, so I know again, so you look at the equation. So for 1 mole of B, 1 mole of B, I need to absorb 100 kilojoules. How much energy did I invest this time? I invested 1500 kilojoules. How many moles do I have? So this just goes back. So you go 1500 divided by 100 in this case, and that will give you 15 moles. Okay, let's just say the molar mass. Now, normally you get given the molar mass. Let's say 15 molar mass of B is, again, let's just say 10 grams per mole, just for the sake of it. Okay, so I know the mole, I know the grams per mole. So that means N equals small m divided by big M, and small m equals N times big M. So it's 15 times 10. So that means my B is 150 grams. Okay, so those two are your most common questions that you get given. And then you also get the, the bonds breaking, bonds making thing. You get a table like this. They give it like CH, CC, and then this give you like 100, 150, they give you those numbers. So you have to remember, for those type of questions, you have to break the chemical bonds first. So to calculate the enthalpy, so you have to look at your reactant, how it's the chemical reactions goes from reactants turn into products. So on this side is bonds breaking. You have to physically break these bonds first to make these bonds over here. Okay, so it's a total of bonds breaking. So you have to identify what chemical bonds you're breaking minus what chemical bonds you are making, and then you do the addition first, and then you got two numbers, take a difference, and that will give you the enthalpy change. Okay, how long have you been a chemistry teacher? Jesus, how long? 12, 13 years now. Yeah, scary. Marketing 11 hours. Well, that's why we're here. Could you go over some shape questions? Yes, I can. Shape questions are pretty straightforward. So let's say, for example, CS2. The first thing that you need to do is understand how to draw Lewis diagrams. Okay, so for CS2, you need to look on the periodic table. So carbon has 6 valence electrons, sulfur has 16 valence. This is 2, 4. So these guys are all in group 4. Okay, so group 14 if you look on the periodic table. So that means carbon, so it's CH2, 1C2S, that has 4, 4, 4. They need 8, 8, 8. So that means right now I have 12 electrons. I need 24 electrons because they need to have 8 electrons in the outer shell. So that means 24 minus 12 equals 12, and 12 divided by, where am I tripping? 3, 4, 12, 3, 8, 20. Wait, I'm silly. Sulfur is in group 16, my bad. So this is going to be, I was thinking of silicon for some reason. So this is 16, 24 minus 16 equals 8. So 8 divided by 2 is 4 bonds. So you need to have 4 bonds. So you have carbon, sulfur, 4 bonds, 1, 2, 3, 4. And then you do the lone pairs electrons to make sure every single thing has got 8 electrons around them. So this is CS2. Now, what shape does this have? So carbon, in this case, have 1, 2 regions of electron density, and they want to be as far away from each other as possible. So you're sitting here right now. What you could do, hold your hand, horizontally. Your left hand, your right hand are as far away from each other as possible. So that's a maximized repulsion. So this is a linear shape. So it's in a straight line. Okay, but if you get something like NH3, nitrogen looks like this. So this has got 1, 2, 3, 4 regions of electron density, but 3 of them are bonded. There's one lone pair which is not involved in the repulsion, not involved in bonding, but it's still repelling the other ones. So they will have, because you got 4 altogether, so this will give you a tetrahedral arrangement. But because one of them you can't see one of the corners, that's why this has a trigonal plane, trigonal pyramid, pyramid shape. Okay, so that's what you do there. Could you please go through organic reactions? Oh yes, Lydia, something to do with KOH aqueous and KOH alcohols. This was even in our year 13 practice exams that we did today, and I think most people that I marked did all right. Looks like they were listening last year. All right. Now this is what before you look at this, all right. Whenever you get the KOH AQ and KOH ALK, and I've always thought of ways for people to remember this. And I this is probably the best analogy. I love using analogies, just trying to make sure you understand and you can remember a little bit better. Okay, so when you dissolve KOH in alcohol, like people drink alcohol, you get drunk. All right, when you get drunk, again, not a good thing, and especially when you get drunk, you lose your wallets, you lose your keys. You lose you lose consciousness. You become unconscious, hangover and all that sort of stuff. So this is when you eliminate stuff, you lose stuff. This is catalyze and elimination reaction, and this is when it's dissolving water. AQ is you're drinking a lot of water. When you drink a lot of water, you need to go to the bathroom to pee, right? So that's replacing the body fluid. So this is a substitution reaction. So so for example, if I have something like this, and I'll do one of the harder ones as well. This is Cl, CH, CH3. I say, for example, if I do this with KOH AQ, all it does is that I'm substituting the Cl with the OH. Okay, so all this is doing is just everything else is just a copy paste, because it's the only thing that reacts is a functional group. So you replace the Cl with an OH, just like what I said about drinking water. Oops, you replaced the original functional group with a new one. When you do the same reaction, the same reagent, but this time you have used KOH alcohol. So this means that you have to remove the chlorine because you're eliminating, you're losing stuff. And then you have to pick one of the neighboring hydrogens to get rid of as well. So you make two products. Okay, so you make two products. So we have a choice. We can either take away this hydrogen, so that used to have two hydrogens, now only have one, and then you form a double bond here. Okay, or you can take away this hydrogen. That means you copy everything else, and then you double bond over here. So you used to have three, but now you have two. Okay, so what has changed? And then we just need to identify which is major, which one's minor. So you look at these. This carbon here had two hydrogens. This carbon here has three hydrogens. And when you're losing hydrogens, it's more likely for the carbon with less hydrogen to lose another one. And this is major, this is minor. So you have to, when you're explaining it, I personally find it extremely easy just to number the carbons, like this carbon number 1, number 2, number 3, number 4. And how I would explain it, I'll just write this, I'll just say, okay, so this is an elimination reaction, which means the chlorine bonded to carbon number 2 has to be eliminated. And then we have a choice, and that means one of the hydrogens from the neighboring carbon, number 1 and number 3, has also need to be eliminated. So carbon number 3 has less hydrogens attached compared to carbon number 1. Therefore, it is easier for that to lose another hydrogen, which is going to give us a major product. Okay, so hopefully that will help you. Where are we? Wait, hold on, I lost track. Enthalpy calculation are done, Gorer shapes are done. What's the main physical observation that we must know? Physical observation. Well, you got your acid plus carbonate, which gives you bubbles. Okay, so this is distinguishing carboxylic acid, bubbles. And then your carboxylic acid and your amine, these are pH sensitive. This is base, this is acid, so they will change litmus paper color. And then you look at solubility. Now solubility means you got functional groups like alcohol, carboxylic acid that will dissolve in water, one layer. Things like alkanes, haloalkanes, they're not. Amines are soluble as well, so alkanes, haloalkanes, they're not going to dissolve in water. 2 layers, physical test. Okay. Which one's this now? Done that. Apart from colors, yeah, I mean, most of it is just color changes as well as bubbles and layers. Yeah. How do you do amine reactions for NH3? Now, Stacy, there for amines in year 12, there isn't much reactions for you to learn. You literally just learn from haloalkane turn to amine, and then which uses conc NH3 in alcohol, and that's it. And amine is basic. That's all you need to do for amine reactions for organic. Because the more amine stuff you learn is actually in 2.6. Let's say if this is amine, this is methanamine. This is a weak base, so what that means, it will partially dissociate, pick up another hydrogen. So this is, if you're looking for reaction, there's one for you, dissociation. Okay. Can you explain how to identify what bond it is in a single bond and what bond is what? Huh? Just no, I don't know what bond is what, like some. Are you talking about the enthalpy equations? I think that's what you're talking about. Let's just do one. Let's say C2H4 turning into plus oxygen. Oh, just hurt my phone as I'm coughing. Let's just balance those 2, 6, 3. Okay, so let's say something like this. How do you know what bond is being broken? So this is where you need to learn. You need to learn your organic as well as your structure bonding. Okay, so you need to, now sometimes it will give it to you, they give you the drawings to you. I think that's a trend now, so I'm going to do that as well. For C2H4, it's going to look like this. For 3O2, O2 is like this. CO2 is like this. H2O is like this. I'm just going to put the numbers in front as well. Okay. So for this, we're breaking all of these bad boys on the left hand side. So what are we breaking? So it's really useful if you grab a highlighter with you tomorrow, if you're sitting a test tomorrow. So what are we breaking? We're breaking CC double bond, one of them. Oops, I'm looking at CC and right CO. And then what else are we breaking? We're breaking, is it a different color? We're breaking CH, we're breaking CH, 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 CH. We're breaking 4 CH bonds, and we're also breaking 3 OO bonds. And then you got those values, so just multiply them by 4, multiply by 3, you know, and this is your bonds breaking. Done. What you should have done is that you should be able to look at your diagram, everything's highlighted. Now let's look at this one. This one I'm making, sorry, this is bond making. I'm making C double bond O. Okay, see the 2 of them. All right, now for every 1 mole of CO2, I make 2 of these, but now I have 2 moles, so that means I have 4 of those. Okay, and same thing with the water. Can you see that we got 1 OH, 2 OH, so that's 2 OH per water, but I got 2 water, so it's 4 water. Okay, so this is 4C-O, this is 4 OH. Multiply them together, you got the table. Find that, and then use this number minus that number, enthalpy. Done. Okay. All right, next one. Quitting chemistry. Oh, that sucks, but you know, it is what it is. What I want to know is like potassium permanganate. How do you use that to distinguish the alkane and alkene, and then what other reaction to do beside bromine? You could use potassium permanganate. Potassium permanganate will oxidize your alkene. If you have an alkene, you're going to break the double bond and you're going to add 2 OHs on there. Okay, so this will go from purple to colorless. Now, if you put this in the alkanes, there's not going to be any reactions. Okay. Yes, organic, you do have to pass. Trust me, you will. If you fail organic this year, you're not going to pass organic next year, unless you just, you know, it's not about like people go, oh, it's my teacher, but it's not your teacher. Trust me, organic is all about spending the time. If you're not good at it, spend the time, you'll be better at it. Is there any tips about sitting the exams? Important things to remember. I've seen people doing this. For the structure and bonding, I think this is for that entire topic. I really think it's quite straightforward. For the organic section, you know, I've seen people going to exams and they write this. They go alkane, I use this ingredients and whatnot. You know, in the back of the paper, I think that's somewhat helpful. However, if you want to practice doing flowchart, like I always say this, start with this. If you want to practice at home, this is your alkane. Can you turn that into alkane? Can you turn that into alcohol? Can you turn this into haloalkane? Can you turn that haloalkane into the alcohol? Can you turn the alcohol to the haloalkane? Can you turn the alcohol to carboxylic acid? Can you turn the carboxylic acid to a carbonate salt? And like the one we did just now, can we turn that into a diol? And then, you know, it's things like this to see if you understood it, okay? And chem is all about preparation. You know, there's hardly any question. You need to apply certain concepts on the spot, but if you've done 5 to 7 years of past exam papers, mate, there's no reason why you can't do one in chemistry, because you will notice that most of the questions are repeated. Then, Liana, can we go through temperature and chemical reactivity? Of course, equilibrium. So if I have an equilibrium like this, let's say 2A plus 1B turns into 3C. Let's say this reaction has a positive 100, you know, same thing I made up before. All right. So what happens if I increase temperature? When you increase temperature, that means you are changing the equilibrium, okay? You are giving the system more energy, okay? That's what you're doing with increasing temperature. And with Le Chatelier principle states is that they always want to do the opposite. Is that if you give it more energy, they're like, nah, I don't want this extra energy. How do I get rid of it? So they want to reverse this change. They want to minimize or reverse this change by, in this case, you gave me more energy, I'm going to absorb the energy. Okay, I'm going to absorb all of these extra heat energy you have given us. I'm going to absorb that into the chemicals. So absorbing energy is the process of endothermic. And then if you look at this chemical reaction right here, this is positive 100. So that means going from, this is always referring to the full reaction. From left to right is endothermic. From right to left is exothermic. So that means we want to absorb energy. We want to favor endothermic reaction. That means the system, this particular reaction will shift to the right, So that means the forward reaction will occur more. And as a result, you are going to have a increase in concentration of C. You're going to have a decrease in concentration of A. You're going to have a decrease in concentration of B. Okay, so that's, there you go. Next one, can we go over pressure question? Pressure question, sure. Let's go 3A. Now I'm going to change this a little bit. Now, let's say this is a gas, turning into 2C. This is also a gas. We don't need enthalpy here. So what is pressure? Pressure is to do with volume. Okay, so if I increase the volume, you know, if you think about your chemistry class at school, you know, 20 odd people sitting in one classroom, right? So if you increase the volume, so that means the 25 of you are now able to occupy the classroom next door as well. Okay, so that means you can occupy 2 rooms. So you have increased volume, so the chance of you banging onto the wall will be decreased. So you have decreased pressure. You increase volume, you decrease pressure. And when you decrease pressure, so that means there's less force hitting on the wall. And you want to minimize that. Again, we're talking about reversing this change. So that means we want to shift to the side with more particles. It's almost like, hey, I got so much more room. How do we deal with this? Let's make more particles. Let's occupy all of this free space. And then if you look at these, this is on the left hand side. This is 4 moles of gas. This is 2 moles of gas. So 4 is bigger than 4. We're going to shift to the left. So we're going to shift to the left, and that means the concentration of A and the concentration of B would increase, and the concentration of C would decrease. And if you don't get why does it decrease or increase, I mean, think about it. If it's shifting to the left, that means I'm making more of this. And how do I make them? Using this. Okay, so that's why. And then decrease volume, increase pressure, just the other way around. Okay. There's no way I'm passing this, not even joking. Well, if you're not passing the school exams, it's not the end of the world. It's yeah, I don't know, man. I've taken all 3 sciences all the way to university, and I think they all get progressively more difficult the more depth you do. And Marvel says physics is the easiest. What are you on about, man? Wait until you do level 3 physics. You're gonna regret what you just said. Did level 3 today? Oh, but it was hell. Oh, yeah, physics 1, but it's easiest. I've always wanted. Yeah. I come to bow. Yeah. My brain, no brain too small. Could you please go over? So Elizabeth, go over polarity. Okay, so sure, polarity. Okay, so polarity, you must talk about 2 things. If you want the excellence, you must talk about these 2 things. The first thing that you need to talk about is the formation of bond dipoles. And what that part actually means, I'll do this over here, I have more space. Formation of bond dipole, it just means like if you have 2 atoms bonding together, you would have created a polar bond. What does that mean? That means one of these guys is going to want, they're going to unevenly share the electrons because one of them is going to want it more. You know, I always, again, with the analogies, think about, you know, siblings. One of them is going to want something a little bit more than the other sibling, so they're going to, you know, use it more often. So, and people go, how do I know which one wants the electrons more or less? You don't need to worry about it. Just need to remember, if you have, you know, 2 different elements, the bond is polar because there's uneven sharing of electrons due to significant electronegativity difference. Okay, so you make polar bonds, you create bond dipoles. And if you want to know what bond dipole means, it just means one of them is slightly positive, one of them is slightly negative. Again, you don't need to know which one's slightly positive, which one's slightly negative. You learned that in year 13. Okay, so once you've done that, we look at the shape. Is the shape symmetrical? Okay, if the shape is symmetrical, then the bond dipoles cancel out. If they're not, then they don't cancel out. And there are situations like this where you may have equations like CH, CH, and then Cl, Cl, and then you may go look at this and go, hey, these 2 cancel each other out, these 2 cancel each other out, that should be a non-polar molecule. Actually, this is polar. Why? Because you have a CH bond, you have a CCl bond, they have different strength in the bond dipoles. Why do they have different strength? Because your carbon is bonding to 2 different atoms. In the first scenario here, your carbon is actually more electronegative, so this is going to take electrons more towards itself, and the hydrogen doesn't really care. In this situation, your chlorine is actually more negative compared to your carbon. So as you can see, the strength of bond dipoles is actually different. If they are different, yes, you can have a what do you call it? You can have a the thingamajiggy symmetrical shape, but then if the strength don't cancel out, like say one person is pulling on the left, one person pulling on the right, yes, the symmetry is here, but if the person on the right hand side is like, you know, 10 times stronger than the guy on the left, you're gonna get pulled over to the other side. Okay. Yeah. Could we go over organic flowchart? Richard, do I really need to go through the whole flowchart thing? That's too long. That's so long. Oh, and Stacy, I just did the dipoles just now. And can you go over how many points each question is worth? Now, Lex, that really depends on what type of question you got given. So that depends on the paper. Like say, but for example, right, your level 2 structure and bonding. So 2.4, your excellence questions are polarity, solids, comparing the physical properties, what's the other one? The calculations. Those are your typical guaranteed excellence questions. For organic, is your cis-and-trans isomers, your flowchart, and distinguishing test. Those are your guaranteed excellence questions. For reactivity, your rates of reaction explanation, the Le Chatelier's principal equilibrium explanation, the weak acid, strong acid, weak base, strong base, dissociation linked to physical properties, electrical conductivities, that is definitely excellence. Okay, so let's go through that. Yeah, Richard, if there's time at the end, I'll do a flowchart, but come on, I've drawn so many flowcharting classes here. Mr. Criswell, get out of here. How many questions do we need to answer to get achieved? 9 points guarantees unachieved. Okay. There's no way of passing. Yeah, that's okay. Memorizing. Yeah. Could you go Y? Go with CH3Cl. Y has a tetrahedral shape. So Iris CH3Cl, despite its polarity, what do you mean? It just has a tetrahedral shape. It's got nothing to do with polarity. So why does it have a tetrahedral shape? Because you got 1, 2, 3, 4 regions of electron density, 4 regions of electron density. All of them are bonded, so therefore they repel. They position themselves as far as possible to minimize repulsion. There, done. Could you please talk about polarity? I just done that. Yay. High risk. Yeah, there you go. Okay, that's equilibrium questions. I did pressure and temperature just now. I can do a concentration one if you want. Let's say if I have 2A plus B equals equilibrium to 3C. So what happens if I increase the concentration of A? Okay, if I increase the concentration of A, what does that mean? So this concentration goes up and you no longer have equilibrium because, you know, the system is no longer equilibrium. So what does the system do? Okay, so you gave me A's, I want to get rid of them. How do I get rid of them? The system will shift to the right. Shift to the right. It wants to get rid of to use the added A concentration. So that means, so you're going to shift to the right, so you're going to favor this reaction. So that means your C concentration is going to go up because you're going to make more of it. Your B concentration is going to go down because, you know, you're using A and B to make C. So that's right. Okay, and with the temperature and pressure, I kind of just did that, so I don't want to repeat myself. Lewis diagram, like, you know, the lines, how to identify the lines. Lewis diagram is always, in year 12, you can always use this method. Like say for, let's pick a hard one, like SO2. All right, so what you need to do, just write them down like this, and then look at the periodic table. These guys in group 16, so they have 6 valence electrons. They need 8 to have a full outer shell. So this is 18, this is 24, so that means they currently have 18. However, they need 24. So I need 24 minus 18, that means they share 6 electrons. That means it's 3 bonds, because 6 divided by 2 equals 3. So just SOO, 3 bonds, ready? So 1, 2, 3, and then you need to make sure every single element have got a full valence shell. There, done. Will the reactants always be broken and the products always be formed? Yes, Stacy, you are correct. Yes, and thank you, Lex. What was the major minor things talking about? Yeah, thank you, Mr. Criswell. Zeta-Varro Markovnikov's rule, that can happen for both. Yeah, Zeta-Varro, some people call Zeta-Varro anti-Markovnikov's rule, which is, again, not a correct name because anti-Markovnikov's rule actually means something else. The cis and trans isomers linked to this. Cis and trans isomers, has anyone explained this? No one did cis and trans isomers. Okay, so cis and trans isomers is an excellent question. All right, so what you want to do, you want to make sure, let's do A, B, A, B. All right, I'm just giving you examples. For cis and trans isomers, you have 2 criteria. You must have a CC double bond, which prevents free rotation, and then you want to What else do you do here? You have CC.1, which prevents for rotation, and then you need to make sure that, you know, look at half of them. Look at the things that's bonding to the carbon in the double bond. These two things must be different. These two things must be different. Those are your number 1 and 2 criteria. Okay, done that. Yeah, Lex is doing my work for me. That's good. Now, because the thing is, like I strongly recommend you guys to do this as well. Like, say if you are really good at a subject, like not necessarily chemistry, but if you're really good at something, it really, you know, not just, you know, I'm not saying that you have to do this, but it actually really helps if you can teach someone, because just while you're teaching someone, you can actually learn and improve yourself. So it's like a win-win situation. Okay. Structure bonding, sorry. Okay, so what was the structure bonding? Okay, so how do you do geometric isomers? I kind of just did that there. 2 criteria. What are the physical properties of all solids? So for solids, has Mr. Lex explained this? No, he hasn't. No, he hasn't. Hey, he hasn't. So for the physical properties of solids, for physical properties, these are the ones that you need to talk about. Okay, can't spell properties. You need to look at these. You need to look at melting point and boiling point. You need to look at malleability and ductility. So how are they you know, able to be hammered into different shapes? And you need to look at solubility, and then you need to look at electrical conductivity. These are your 4 most popular ones. Almost popular there. Conductivity. Okay, so melting point, boiling point. So you just need to say molecular solids have really low melting point, boiling point because their intermolecular force is really weak, doesn't take a lot of energy. Ionic solids is not malleable because if you apply force, ion bonding breaks. So positive ion next to positive ion, negative ion next to negative ion, then breaks. Solubility, why does MgCl2 dissolve? Actually, this one sucks in terms of solubility. Why does NaNO3 dissolve in water, but Na doesn't dissolve in water? Okay, so you know, you talk about the force of attraction between the solute and the solvent, and compare that to what they would become if they were to dissolve. And electrical conductivity, why are metals good conductors of electricity? Because of the free delocalized electrons. You know, just these are your 4 main bullet points for that. Okay, anyone done biomark? Yeah, it's really, guys, I think it's a bit unfortunate that probably all of you here missed the exams last year, and that probably, so you're not really used to exam revisions or how to go about it. And I will personally recommend that do, for science subjects anyway, just do the old exam papers. It's by far the best way. Okay, by far the best way. Stacy, which solids are polar and which are non-polar? Solids are polar or non-polar? That depends. Oh, you mean these types of solids, like molecular, ionic? Well, polarity only refers to molecular solids, and that depends on the symmetry and stuff. Okay, and you still don't get the isomers. Okay, that's fine. That's okay. All right, let's draw you one. Let's draw this for you. It's okay. That's what we're here for. No one's gonna judge. If you don't get something, you ask, and that's something I can't emphasize enough, and that's something I personally don't really like about my students in my current school. You know, lovely students, but they don't ask for help enough. You know, if you don't know something, just ask. That's what we're here. That's what we pay to do. I'd rather you ask and help you than you failing, and then both of us feel miserable because I feel that I haven't done my job, and then you don't get the grade. So, you know, just ask for help. All right, so let's look at these two. So these are structural isomers. So can you see this is a structure? They all have 4 carbons. But if you look at this one on the left, the question is, can that have geometric isomers? And the question is no. Yes, it has a CC double bond, but then can you see this? Look at the carbon here. This carbon is bonded to same groups. This carbon is also bonded to same groups, so this have no geometric isomers. For geometric isomers, you must have CC double bond. You must have two different, the two groups bonding to the carbon must be different. So if you look at this guy, this satisfies the criteria because you have a CC double bond, and then you have a CH, you have CCH3. So these are two different things, H and CH3. This is two different things. So this is a cis isomer because all of your H's are on the same side, your CH3s on the other side. How do I draw the trans version? Trans is the opposite. So that means your H's are on the opposite side, your CH3s are on the opposite side. Okay. Have I covered chemical reactivity? Jinhu, I did equilibrium. Yeah, quite a bit of equilibrium. The equation thing to find change in H or something. Dude, man, like, can you make it more specific? What do you mean, the equation thing to find the H or something? That is, I can't read your mind, man. You're welcome, Stacy. Any more questions? Just chat them here. Because it's quite a lot of content, especially if you're sitting an exam on this, like someone said, in 11 hours. Yeah. Can you show me how to do the pH with logs? No problem. pH of logs. Okay. So pH. So these are the two equations you need to know. pH. Okay, so pH equals negative log H3O plus. That's what P stands for, potential. H stands for hydronium ion, so it's a potential of hydronium ion. And then if I know the H3O plus, this is 10 to the power of negative pH. This is just the inverse of negative log, which is 10 to the power of negative pH. Okay, let's say, for example, if I want to calculate the pH of 0.2 moles per liter HCl. So my HCl will completely dissociate, so I know the concentration of HCl is 0.2. So I know my H3O plus concentration is also 0.02. Is also 0.2. So how do I figure out the pH? So I just literally just go negative log 0.2. So on your calculator, like, people get confused. How do I do negative log? So you just press negative, press log, press 0.2, and then you get the answer as 0. Make sure you round to 3 as if 0.699, and this is your pH. Okay, now, and then you may go, all right, so how do I find the pH of, or if I know the pH equals 1.5, what is the concentration of hydronium ion? And this is where you just go, all right, so H3O plus equals 10 to the power, pH, 10 to the power of negative pH, so just 10 to the power of negative 1.5. So you literally just go on, you calculate 10 times 10 to the power of negative 1.5, and that will give you 0.0316 moles per liter. Okay, that's how I do that. All right, gonna go by. Could you go over solubility for organic and bromine water? Oh my goodness, what is that question? Let me read this, Stacy. Yeah, see you guys. You don't have to stay. You can watch the VODs later. What's this question? Could you go over solubility for organic in bromine water, alcohols, amines, carboxylic acid, determine whether, oh, okay, so you got alkane. Well, this is not solubility. I don't know. It's not solubility, Stacy. I don't know what you're doing here, but you're looking at alkane, alkene, alcohol, amine, or carboxylic acid. All right, so how do you distinguish this? For these two, use bromine water. This one changes colorless straight away. This will take us a few minutes. Done. Amine is a base, litmus paper. This will go blue. Oh, sorry, blue. Yes, it will turn blue straight away. Carboxylic acid, you can also use litmus paper. You can put this in a carbonate. Bubbles, CO2 gas, and the leftover is alcohol. Done. Oh, and the solubility rule. Solubility rules, easy as these two, insoluble in water. So if you put them in water, they're insoluble. You see 2 layers. Think of this, like if you see petrol, if you see all the incidents of oil being leaked, oil and water don't mix. Oil is made of alkane, you know, insoluble 2 layers. These guys, soluble. Okay, so you see 1 layer. Done. Okay. And polymerization, polymers. So in year 12, you only do addition polymerization. I think this turned into a Stacy 101 tutorial. Not a problem. So additional polymerization. So with additional polymerization, so this is what you do as you need to have an alkene. I'm just drawing a random stuff here. Like how do you figure out how to draw the polymer? You literally just put them right next to each other. All right, I'm just gonna draw 3, because why not? 3 is a good number. Cl, CH3H. All right, ready? Now I'm going to put them together. I'm gonna break the double bond, and I'm gonna join them together. And this is my polymer. And to go back, you just look at the repeating units. I mean, you can clearly see these things repeated. Copy one of them out, you know, just copy it out, don't do anything yet. Cl, CH3H, just copy it, and then look at the polymer, monomer, sorry, just do double bond, okay? And Tech Gaming Smart, are you able to explain the flowchart for organic in past NCEA exams? If you look on my YouTube channel, I've gone through every single paper from 2018 to 2021. So you can find that particular question on organic flowcharts and just, you know, listen to the recording and go through that. Okay, because flowchart is actually really big to go through in a short amount of time, and especially if you're looking at specific exams, that's where you need to go. Okay, what's the difference between hydration, halogenation, dehalogenation, and dehydration? Stacy, so those names, I don't even use them, okay, because I don't like them. Because hydration is just adding water. Okay, this is, I mean, think about hydrate, you know, keep hydrated. Hydration, just adding water. Halogenation, it's just adding halogenation, it's just adding halogen. Okay, so you're adding halogen. So that means you're adding stuff. So these are all addition reactions. And then if you think about dehydration or dehalogenation, they are all removing stuff, removing halogen, removing water. So they're called elimination reaction. So elimination reaction, you're making double bonds, you're making CC double bond. Addition is that you're breaking CC double bond and you're just adding things onto them. Okay. Hello, Ashley. If you react alkene with that, do you get a brown precipitate? No, you don't get a brown precipitate, because you said it yourself. You are going from alkene. Alkene is a double bond. If you add this with MnO4 minus H plus, that means this is acidified. When you have this chemical reaction, you break the double bond, you add the 2 OHs here. And this color change will be from purple to colorless. Now, if you get alkene with MnO4 minus, no H plus, that is when you have a brown precipitate. Okay, so that's how, you know, it's the key thing is here. Okay, so when you see this is purple to colorless. When you have this only, nothing else, purple to brown precipitate, or just, you know, a brown yucky solution. Okay. So surely go, dude, I've just said gone through 5 exam papers in the past 4 or 5 years. Go, not 4 years, in the past year. Go watch them yourself. Yeah. Live better so I can ask questions. Okay, live's better. I know it's live's better, but you know, I'm not going through exam paper if I already done it. Man. You can just, yeah. I know you Siebes. That's all you do. You just can't be bothered. Could you go over salts again with carboxylic acid? All right, carboxylic acid again. So carboxylic acid. How can I do this in a different way? Let me think. in a way that's a little bit different to how I did it the first time. You know how in acids in year 11, these are the acids that you learned, right? And then this is something I normally ask my year 11 to do, and every single one of them will be able to tell me that all the acids have H's, so they all lose the H's when they react. So this will react, this becomes something nitrate, this becomes something chloride, this becomes something sulfate, okay? So same thing with your CH3COOH, like carboxylic acid. Again, it's a H. So what are you left with is a CH3COO, So this becomes CH3CO minus, this becomes something 2 minus, 1 minus, 1 minus. So with the carboxylic acid salt, let's say if I react CH3COOH plus sodium hydroxide, you need to understand that it just this H goes away with this OH here, they make water, and then the leftovers combine together. So it's CH3COO and then they, you know, it's literally year 11. Except how is it different? Instead of writing HCl, I wrote CH3COO. Instead of writing Cl, I wrote CH3COO, and the charge is still -1. That's all there is. Okay, and combustion and incomplete. And Stacy, I wouldn't care about combustion or incomplete combustion. I can tell you that right now you're not going to be asked about those. Complete combustion, it just means you plus oxygen, you make CO2. You just have any organic products, you make carbon dioxide and CO2. This is complete. Incomplete, you just have a little bit of oxygen. For example, you make carbon soot and water, or you make carbon monoxide and water. This is incomplete, not worthy to spend time on it. Not going to be in the exam. And then last one, could you go over cyclo? Cyclo, let's say for example, if I do C6H12, can you see this 12 is twice as big as a 6? So that means this is an alkene. So I can draw one right now. How do I draw alkene? 6 carbons. Boom, boom, boom. This is a 6 carbon alkene. You know, if I do the H's, you can see that if you add up the carbons and hydrogens, these will equal to C6H12. I can also draw it like this. This is cyclo. And that's as much as you need to know with cyclo stuff, anything really. In year 12 and year 13 NCEA chemistry, we don't look at cyclo at all. If you look at Cambridge A-level chemistry, the entire organic topic is about cyclo, but we don't do that in NCEA. Okay. Look at that. Who's complaining? That looks like Alex. Oh, of course. He was complaining before the exams. Now he's complaining after the exams. No worries, Stacy. I'm pretty sure the questions that you asked is, you know, probably other people want to ask as well. I'm not gonna sweat. Yeah, whatever, man. You're just making excuses for the not so good grade that's about to come up. You know. Good luck with physics tomorrow, by the way. Yes, Jinho receives is all you do. So, anyone else have any questions? Because it's getting late into the night. Because a lot of my guys have physics exam tomorrow, so I don't want to do this for too long. So what I will do for the end of the year, is I'll definitely run another tutorial, at least one, and it would definitely not be the day before the exam. It will be probably like a week ahead or a couple of days ahead, just to give you more time to do those. Redox equations, redox are not in, it's not external, so you don't do redox equations. That's an internal topic. You're already done with that. No need to do redox. No problem, Iris. All the best. Cool. I think, yeah. I wasn't going to do this for more than an hour and a half, so we already done this for like an hour. So, and I think, unless you don't have any questions, we'll just call that a night. Okay. Because, like I said, you'd have tons of content on my YouTube channel. You can just you know, look for them, look at the past exams, and yeah. Oh, that's good. That was helpful. That's the whole point of this YouTube channel, just to make sure that people like you that do struggle get some help, you know, because asking for help could be a difficult thing. And yeah, sweet. I think everyone's pretty happy. Okay, all the best with your school exams in the next few days, and I'll definitely be back with some more streaming or content in the near future, probably during the holidays. Yeah. All right. Have a good night, guys, and all the best with your exams. Cheers. Bye bye.